Yes, sir. Okay, so welcome to the fourth session of the LLMs reading book. So I hope the micro is highlighted. Okay, I'm not gonna move too much just in case, right? So I hope it works now. Can you hear me well at home? Okay, I hope so. So yeah, we are starting the session today is reinforcement learning from human feedback. Okay, which is mostly a set of techniques that well, companies like OpenAI or ChatGPT have to use on top of a fine-tuned large language model. Okay, because let's say we just want to control the behavior or the values that this large language model represents. So in order to not generate illegal content or harmful content, right? It's like a way of techniques to steer the behavior of a large language model using reinforcement learning approaches. All right. So just a brief presentation about me. My name is Victor Gallego. I'm the co-founder and chief scientist at Cobrevit, which is a startup spin-off of the IFEMA, per se. And this is where I did my PhD thesis with David and Ray. Okay, so I thank them for inviting me. All right. So if you're ready, let's start with the contents. Well, first, this is the outline. Please just ask me questions at any time. Okay. We're just gonna do a brief introduction, then delve into the details about RL HF methods. Okay. And then we just review some actual research topics. Right. This thing.
A lo mejor se puede bajar el volumen.
Yeah, I think I'm just gonna. Let's see if now. Yeah, I think it's better. It was too high. Sorry. Okay. So yeah, just ask me questions wherever you want. That's it. Okay. Try to make this more of a discussion. All right. So the motivation behind this is that large language models can be very powerful, as you know, but they also can have problems because, as Carlos told us the other day, they have been pre-trained over large amounts of text from the internet. The problem in the internet, as you know, there is a lot of biases and like hard content that can be harmful. Okay. So this set of RLHF, like reinforcement learning from human feedback, aims to just translating some kind of notion of human intent and values to the fine-tuned language models. Okay, so we can control the language model. Okay, so for example, when we ask ChatGPT, for example, can we make a bomb with household materials? Then the model tells us making a bomb is harmful and you shouldn't do that, instead of just telling a recipe using. So they have done that using the techniques that we're going to cover there. Okay. The thing is, so yeah, the question is, how can we imbue human preferences into a large language model? Okay. The thing is, it's difficult because, you know, we will have to just specify some kind of behavior, like don't be bad, don't generate harmful content. Okay. But the problem is that requires large amounts of human annotation. Okay. So instead, in the simple methods we're going to be seeing today, they have been specially prepared to be scalable. Okay. And that we can just annotate examples using some kind of signal, like from these two sets of outputs, this one is the best one I prefer. So then the thing is, we rate several outputs. Okay, we have the details in a few moments, but that's we have a person that picks which is the best answer for a set of options, and the model learns like the human preferences, which are implicitly represented by this preference between options. Okay. So in the case of OpenAI, the labelers, the human operators. Okay. So a very simple task, and this is the case for reinforcement learning. Maybe I can just a little bit. Let's say we have some kind of prompt, and we just want to generate movie reviews, okay? And we want to make the model to just generate positive movie reviews, okay? So for a single prompt, the movie, we have two completions, like the movie was awesome, amazing cast. Another one, the movie don't watch it, it's completely shit, okay? If we want the model by default can generate these generations, but if we just want to focus on positive ones, we can just steer the behavior towards positive sentiment, okay? I mean, there are several ways to do that, but the one we are going to focus today is using reinforcement learning. Okay, sorry, because it's that. Oh. Let's hope it's better. Okay, so in which we just specify there's some kind of, I think it's my arm, it's some different reference. So in which we specify some kind of reward, which is like a score, okay? So the behaviors we want to promote, they gave a positive reward, and the behaviors we don't want to promote, we want to eradicate, or we get a negative reward. So then with reinforcement learning, the model steers towards the positive ones, okay? The key point about this is that instead of having to write generations, we let the model generate. It's automatically, no? The humans only need to provide the signal, these rewards. So it's easy because it's just like rating. It's like in ChatGPT when you have the thumbs up or thumbs down to rate a duration, okay? So this is a scalable method to just gather preference data, which is in this form, okay? But we'll see the details now, all right? Of course, this is a very simple example, just sentiment analysis. Typically, reinforcement learning for large language models is for more useful tasks, which are typically to improve helpfulness in assistance or to also improve safety content, to have ChatGPT like avoid generating illegal or harmful content, okay? So let's continue a little bit. Okay. So yeah, this set of methods, they are a key factor in all the big players today, like ChatGPT from OpenAI, Gemini by Google, Cloud by Anthropic, and also the open source models, okay? It's a way of, okay, we have a pre-trained model, trained with supervised fine-tuning, okay, which was the previous session. And then with reinforcement learning from human feedback, we aim to improve our some axes, which can be helpfulness and harmlessness, or whatever preference we want to do, okay? Yeah, that's pretty much it. So there are some presumptions of reinforcement learning from human feedback. Also, you have to take into account that as you know with deep learning and large language models, the papers are very empirical. They are like mostly engineering papers. So, but there are some assumptions that is good to know. Okay. So the first thing is that, okay, we are going to believe that reinforcement learning works, which is that it's like a recipe of finding an optimal solution. And the optimal solution is going to be an optimal large language model. Okay. That can maximize some reward. Okay. We are also going to believe the von Neumann strength utility theorem. Okay. Which is that, okay, people have preferences, like people prefer safety behaviors versus illegal behaviors, okay? And we can represent those preferences using a utility function or some mathematical function that then can be maximized, okay?
This very, I mean, this, as you said, is very subject dependent. They versus probably different to what I prefer.
Yeah, the thing, what they do, especially in language model, is they aggregate the preferences of a very large amount of crowd peoples. Okay.
But the other thing is the way reinforcement learning works, but it requires lots of opportunities.
Oh yeah. It's possible, but the thing is, if you have a lot of people who write responses, it's scalable. Okay, so it's the best scalable way using this, so that's why it's important. Okay.
Yeah, just to be honest, no, I would like to very quickly jump in on Danny's point. I think that essentially, what we are speaking now, the end is about the notion of ground truth, which of course, has its origins, with in the whole so-called frame problem, which was proposed, in the end of the 60s by John McCarthy and one of his co-authors, So I think, basically just to sum it up, so it's essentially, I mean, we could essentially outline, three main points, so of course, state comprehension, then it's about, perception, it's about, it has its origins, in the frame problem, in how we frame, our perception, and then of course, it's of course, it's a part, it's largely developed by the companies, then of course, it's about commercial interests.
Yeah.
Because I mean, sometimes, there is a conflict even, between perception, of the frame problem and the connection interest.
Yes, that's a good point. What is your name? Sorry.
Yes, it's Akio.
Mateo. So that's a good point because, yeah, I think it's related. So you are maximizing some preferences by people, but it's usually what the company like OpenAI want to maximize. Maybe it's preference or safety, but representing some kind of the population. So it's quite controversial, especially there are lot of papers about ethics, which deal with related. Okay, but we can discuss it later. Good point. Okay. Another important part is the Bradley-Terry model, which is one of the most fundamental statistical models to represent reference data. It was proposed in the 50s, I think, in the Biometrica paper. Do you remember it? Yes. Oh, I can.
Yes, because I think it's
Okay. So yeah, maybe it works better. So yeah, the Bradley-Terry is, we wanna introduce the model later. Don't worry. And yeah, mostly aggregation of preferences in which we have a large pool of people voting. So in the end, the aggregation is going to represent something we want to pursue. Okay. Yeah, this is the application to large language model is quite recent, from 2020, in which we have the InstruGPT, which is like ChatGPT antecessor. These methods, the Bradley-Terry model, comes from the 50s, where people started developing decision theory. Okay. And so we have some results from reinforcement learning that apply here. Okay, but just a general overview. Okay, the application of these preference methods, it's quite novel to large language models, but of course it relies on a lot of theoretical developments from before. Okay, but just to not deviate too much, we can talk about this later. Okay. Before I continue, I don't know if you are familiarized with reinforcement learning. So I'm just gonna very quickly review what reinforcement learning is. Okay. So we have some agent represented by a neural network with some theta weights. This agent could be a robot or could be a large language model. Okay. This agent produces an action. This action could be a movement of the robot or a generation, some text that the large language model has generated. Okay. So there is an environment that making on some simulator, and we receive a reward. Okay. This reward could be tell us that, okay, this text is good or this text is bad. Okay. And then the agent, using the feedback from the human, updates the weights to learn. So it's like a loop, okay, in which the agent is taking decisions, which in the case of a large language model is generating text. It receives feedback from a human and then updates. Okay. So it's quite simple. And of course, the goal of the agent is to learn some kind of weights, to learn a policy, to learn a large language model, that over time, it maximizes the rewards. Okay. That's very simple. So in the case of the application to large language models, okay, the agent is going to be the LLM or model, which is of course a transformer rates model, like the ones we explained on the previous sessions. The action is going to be the completion to a prompt, like the response. This is going to be the reward. It's going to come from, well, first a human, but we are going to build a model for this. And then the state is just a prompt. So for example, generate a movie review, and it is the actual review. And we want to check if the review is positive or negative. So I do the reward. Okay. So quite simple setting. So of course, reinforcement learning from human feedback is not new for LLMs. It was applied before, typically by DeepMind. Okay, in which we applied, well, to robotics, in which we have some robot that has to move around an area. Okay, and we have some human feedback, which is a human telling if the trajectory is good or bad. Okay, so like imagine you are building a flight simulator. The agent is a plane that is controlling the altitude, longitude, and then the reward is provided by an expert pilot who tells if the trajectory of the plane is good or it's bad. Okay, but these are like two antecessors for reinforcement learning from human feedback applied to robotic tasks. Okay, the first application of RLHF to language modeling is this important paper, which was in the introduction of this language group, okay, which is the paper by Ziegler, okay, at OpenAI, in which they train a model, okay, to improve the summaries, okay. It's the first setting, and we're gonna study this in further detail, okay. So the thing is, okay, the goal of this paper was that, okay, they want to optimize a large language model, but to produce summaries that are preferred by the most people, okay? So the setup is, you can imagine, we produce the same language model, produce two different summaries of some text, and then we have people rating which summary prefer, okay? And in the end, we can just they further optimize the model to improve this preference for the people, okay? But we're gonna see the details very soon, okay? Yeah, in next year, the OpenAI has also provided a similar paper, okay, which was already introduced in InstructGPT, which is like some kind of the parent of ChatGPT, all right? But this is the diagram of the process, but I'm just gonna introduce it later before, okay, in a few moments, right? So now let's get into the details and the optimization problem that we want to solve, right? So the thing is, there are like three phases of reinforcement learning from human feedback, okay? The first is to start with a supervised fine-tuned model, okay, which is the last session we have, which is we have some kind of large language model that already knows how to answer some questions, okay? Because it has been trained on a set of question answers, okay? But then we want to further optimize this, okay? So we are going to start collecting preferences, which, as I said before, is like which completions people prefer more, okay? So we collect preference data, okay? And then on top of that, we further fine-tune this model, but with a different approach to optimize the preference of the people, okay? And this is the reinforcement learning part, very simple, okay? We're gonna go step by step now, okay? So now we're gonna introduce the formulation. This comes from the Ziegler paper, but most reinforcement learning from human feedback papers use the same problem, okay? It's like, I mean, it's quite simple. It's not very complex maths, okay? But let's go step by step, okay? So the first part, we want to maximize the policy p theta, okay? This would be like p theta is like well, the model we are training, okay? We are optimizing the weights, and by weights I refer to the linear weights and also the weights of the attention layers, both of them, okay?
So the whole model is fine-tuned. There's nothing frozen.
Yeah, you typically optimize the whole model, but well, then you can froze some layers so that, but yeah, you can optimize the whole model, okay? And of course, our objective is to maximize some reward. This R, we are going to define later, but it's a function of X and Y, okay? And X is a prompt or a question, and Y is a completion. So we have a function, a reward function that rates, given this prompt, how good is this completion or not? But we have to build this in a few moments, okay? So for one part, we want to maximize this, and this is a stochastic, okay? Because this is an expectation, okay? We generate prompts or questions to a set, and then we generate completions by the model, and we evaluate how good are those completions. So we want to make them as good as possible, okay? But, well, this is an empirical thing. There is no real justification a priori. If you just maximize this, it like overfits, because this reward can be an approximation. So the model learns to over-optimize this, and it's really a bad objective, okay? So what is done is typically to add a regularization term, which is the pullback-Leiber divergence, okay? Well, I'm sure you know, but this is like a kind of distant measure between two distributions, okay? So we have the distribution of outputs of the LLM we're optimizing, and this is our reference model, okay? The thing is, at the beginning, these are the same model, the same language model, okay? But we keep a frozen copy. without optimizing, and then we optimize a different copy. So we can compare how the log is changed from the model that is being optimized versus the original one. Do you understand this? Yes. The thing is, this is a realization term to avoid this distribution changes too much versus the base model. Okay? Because the thing, if you don't have this, maybe the optimizing model changes a lot, and then what happens is that the grammar breaks. So the model starts to generate output too fake that just to maximize this. So this is to control that the model doesn't deviate too much from the original model while still maximizing a little bit the reward. Okay, so it's a trade-off.
It's like variational inference using the original model as a problem.
The thing is that variational inference is a good connection, Carlos, because you can see in a few moments that really this is Bayesian inference.
Yeah.
You can frame that. Okay.
These are distributions over discrete spaces, over tokens of the dictionary.
Yeah, this is like the autoregressive distribution over the completions. So this could be a multiplication over each token.
Okay,
And each token is a categorical. So yeah, it's easy to evaluate because it's just.
And to approximate the KL, you compute it exactly, or you sample from the.
Well,
you sample from the completion.
Yeah, you sample from the completion, and then you just compute the logics for it. Yeah. But yeah, everything is done sampling. Okay.
Can we consider the second term as a regularizer?
Yeah, I think so.
Pretty much, right?
Yeah.
The virgin is.
Because this is a different measure, so it's a number positive than zero, right? And it has a negative symbol, so it controls this. But it's important because people notice that if they don't have this part, the model breaks because it optimizes this too much and then it generates like rubbish output. So yeah, that's the part. But the things, a priori, there is no other argument for this. It's just an empirical observation of people, okay? But there is an interesting result in a few slides, okay? So yeah, this is the same. We optimize our reward, but we add some penalty term here to avoid breaking the model. It's like a control, okay? And now I'm gonna do a detour because I know a lot of here are Bayesians. The thing is, there is a nice paper from 2 years ago in which this RL with KL penalties can be seen as a Bayesian inference problem, which is what you were suggesting, Carlos. Okay. So the thing is, maybe you assume you have the original language model here. Now X is the whole generation. Sorry about the notation here. So maybe our original model generates a lot of samples in this area. Okay. And we want to steal the behavior to a particular area. Okay. So then, what is our likelihood? Our likelihood is going to be like the reward model. Okay, this is like an energy-based model. So we have the rewards and then we just normalize. So maybe we, instead of all this space, we just want to focus here because it's the area of positive reviews or the area of safety. Okay, so taking this if this is a prior and this is the likelihood, we can just compute at least define some kind of posterior in which the mass of generations is now more focused towards the likelihood because we want to sample now in the areas where the reward is more positive. Of course, we need to normalize that, but this is okay. So in the end, we want to do this. We want to get this model. Okay. The problem, as you know, this is not feasible from this because it's Bayesian inference, so we have to compute the normalization and that stuff. Okay. So typically, what people do is variational inference, which is one of the approximate techniques for Bayesian inference. Okay. So we would like to find some variational approximation towards this optimal posterior, the true posterior. And in fact, what I was suggesting in this paper, okay, they see that solving this problem is exactly the same as the previous one. So it's a quite interesting interpretation. Yes. Yeah.
It's not so much how can it be done, because I don't about of course, for smaller large language models. But how it is usually done in industry, nowadays. So about the reward model, is that still relies, on manual annotations mainly, or is already, being automatized?
Yeah. Well, most of the options. There are some datasets that are manually labeled for doing that. But also you can have, this is the last part of the session. You can have a different language model to just evaluate preference. So to build a reward model automatically. but that's not RLHF, it's RLAIPR. Okay, so yeah, but nowadays they're using both. Okay.
Yeah, I mean, I was referring like to really large companies. I mean, you know, not a small work, you know, which can be done by us, but for example, you know, the way, for example, OpenAI, you know, Gamma, you know, Microsoft, the way they open.
Yeah.
Because it's curious, because on one hand, because, you know, they have enough budget, you know, because in this case, you know, Microsoft is that, you know, manual annotation would be more precise, you know, and more aligned, you know, with interest. And of course, you know, they have the budget, but also, you know, because they have this very technically utopian thinking, you know, so of course, you know, they're of course very keen on automation.
Yeah.
You know, so it's just curious.
Yeah. For example, Anthropic is doing automatic thing, which we will review it later. Yeah. So yeah, in the end, what if you prefer this interpretation, what we are doing is we have our general language model and we are aligning it towards our reward model. Okay, and we can solve these problems, they are equivalent. Okay, so let's go back. And so the proof is quite easy because it's just a few steps. So the paper is quite short and nice. Okay. So now let's go back to our original problem. Okay, let's think this is the objective. Okay, but we have to still take two decisions. The first is, okay, we have a reward model, not just rewards, but actually a whole model that runs. So we need to define that reward model that is going to learn from the human preferences. Okay. And also the second decision is, okay, how do we optimize this? Okay. That's the error part. Okay. So for the reward model or preference model, I mean, reward model and preference model, we can treat it like synonyms. Okay. So the thing is, we use this is where the Bradley-Terry model enters the scene. Okay, it's a very basic model. Okay, so the thing is, okay, maybe we have some prompt here, and we have two completions, I1 or I2. So we can define some kind of probability that we prefer I1 versus I2 as this ratio. Okay, and this ratio is nothing more than the reward. The ratio of the rewards normalized. So the reward can be positive or negative. So we take the exponentials and then we just normalize to compute probability. Okay. Yes.
Couple of questions. The first one is, so far you were just saying we have this completion and you say okay or not okay, but now you're comparing two completions.
Yeah. The thing is that typically, well, there are variations. Typically is you have one prompt, several completions, and the signal is which one of these two you prefer.
But both of these completions are generated by
by a model, by the same model.
Yeah. And the second comment or question is this is Bradley-Terry's, right? But there's many other choices.
Yeah. The thing is, people just use because I think computer scientists don't know more preference models, so it's the basis one.
People have tried others.
Yeah, the Flacket-Lewis, and also some, because here you just tell one or the winner, but you could impose some ranking. The thing is, the more structure you impose here, the most difficult to collect data. So with the Bradley-Terry it's quite easy because for every two completions, you only have to have one person pick which is the best one, and this can be doing very easily. And this is an important point because choosing the preference here is much easy, and it's cognitively easy than, okay, for this one, I assign it a score, and for this one, I assign it a score, because it's easier to just pick one than giving a score for each and then comparing one for a human. So in the end, you have to think that this is a very simple model that escalates to a lot of data quickly if you have humans. Okay. So yeah, this is the definition of the Bradley-Terry model. Okay. So now, if we have data on this form, we can just optimize our reward model, which is going to be another neural network. Just build some estimates for these probabilities, and then finally, our original model is going to optimize this quantity. Well, these rewards, not the other ones. Okay. Yes.
Sorry, just a very small one. You know, I was thinking about earlier, you know, because you introduced, you know, the point made by von Neumann, you know, and Morgenstern, so I was just thinking, that really, in this case, as long as, transitivity principle, is respected, you really could introduce, as many scenarios
Yeah.
as possible,
Yeah,
No,
totally.
I mean, you really just have to respect, so this is a little bit linked, to what David said, you just have to respect, transitivity.
Yeah.
And you can additionally, introduce multiple pairs.
Yeah, that's a good point. Here, for example, in LLHF, you have to assume transitivity. The thing is, it's quite a not very realistic assumption because if you have a large amount of people, preference cannot be transitive.
Yeah.
So that's a good idea for a paper. I know people are working on that kind of problems to change the axioms and to build different preference models to allow for non-cycles or non-transitivities. Okay.
Yeah, that's what
Yeah, there are some examples, but for as I know, or what people publish, OpenAI and this, they just assume transitivity and keep it simple. That's it. Okay. So yeah, this is the thing. Okay, now how we collect the data? Well, we have talked about this before. We assume some kind of chat conversation, and then the model generates like 2 or 3 different alternatives. Okay. Oh, because it's you just you resample, like you generate. It's not so the model is important. It's not greedy decoding because greedy decoding is gonna be deterministic. You sample from the logits, so then you change the seed and you get different results. Okay. Well, this is typical interface. So we have a conversation between a system and human, and then for a human question, now the same model generates 2 outputs. And now the human just picks A or B. I mean, this is the basic one, but you can have some kind of Likert scale from if A is questionable or not. But in the end, people just filter the medium and it's like binary preferences. Okay, it's quite easy. Yeah, so we have the preference data. Okay, what is the structure of the reward model? Okay, well, the reward model can be the same LLMs as before. The thing is, we replace the final layer to just output the scalar thing. Okay, because this model, remember that the preference model just runs. Okay, so it can be the same LLM as before. So it has a lot of knowledge because of the pre-training, but we have to fine-tune the final layer to just output the scalar one. Okay, but we're gonna see the problem now in a moment. Okay,
and this reward model is fixed during training.
Yeah, once the reward model is learned, yeah, it's freeze, and then you train the other LLM which in that model. Okay, so for example, typically, let's say you have a mini batch of 2 examples, one the preferred completion and the other the discarded completion, and the model is gonna learn which is the preference. Obviously, at the end of the training for the selected completions, we have high probability and the others none, and we learn that. Okay, so the loss. Okay, so if we have the regulatory model and we want to optimize this model, we can just take the log likelihood of this as the loss function, and we learn that because we have data of this form. We have a prompt and we have which option was preferred by the human. So we can just learn this R here, which could be the final layer of the model. Okay, there is a note. Well, there are some slight variations. For example, in the paper by Ziegler, if you open the paper, well, I have this, but it's going to show you what they do is instead of generating 2 and choosing the best, they generate 4 responses and you pick the first one, the best one. So it's the same objective, but with just 4 responses. Why they do this? Well, they say it's just to amortize the cost of a human reading the prompt. So there is more variety, but in the end, it's the same regulatory model, but it gives more. Okay, but that's the loss function they use in like every paper, which is the log likelihood of the regulatory model. Okay, so there is a lot of research opportunities in changing the loss to other structures. Okay, but what you have to recall is that okay, if you collect data, you have to collect data for the appropriate rows, and this is the simplest rows for us because you have to just pick one. Okay. Then, so assume we train our real model. Now, the last part is the reinforcement learning part. Okay. The thing is, we cannot do cross-entropy training because the outputs are being generated by the model. So we cannot backpropagate through the outputs because it's a discrete decision. Okay. So I'm going back to this. Just let me, because notice we are sampled here. So these are not written messages. These are sampled by the model. And we cannot backpropagate through this because it's a discrete decision. Okay. But this is like reinforcement learning. This is like an action. So we can use, well, what people use, we could use any policy optimization method, but people use PPO, which was introduced in 2017 by Schulman for robotics, but it works well in practice. Okay. This is just like taking the gradients, but with respect the expectation. Okay, it's just an optimization problem, right? It's not really, it's like the equivalent of Adam, but for reinforcement learning. Okay. So the pseudocode is the first, is this way. It's just a pseudocode, okay? We generate some responses from LLM, okay? We just compute the rewards for each response through our preference or reward model. And then we just update with PPO to maximize the rewards, okay? It's this is just a routine. There is nothing interesting about this, okay? This is just a diagram of the process. Well, because people in deep learning love putting diagrams, okay? But you know, we have our problem data set, okay? So we have our original language model and a copy that we are training, okay? So we generate a response, and we rate the response with the reward model. So we get the reward part. But remember that there was another term in the optimization problem which compares the logics of the updated model towards the logics of the original one. So to not deviate too much. So we add them together. This is our output. And then we just do an update of gradient descent, but policy gradient descent with PPO. But then we retrain, and it's done. So then in the end, the hope is that the rewards are positive, more positive. Okay? Yeah, this is just the reference part. This is the other part that controls that the model that we are learning doesn't deviate too much from the original one, and just the completions, okay? And that's pretty much reinforcement learning from human feedback, okay? This is just a recap of the process, okay? This is what people do, like every paper. So first, you train a supervised model using supervised fine-tuning. So the model can know how to answer basic instructions and prompts. Then you just collect reference data, which, as we have previously, is just choosing the preferred alternative. And then we further optimize to maximize the reward. These are the 3 steps. So we start with SFP, which was in the last session, the preference model, and then the optimize the reward. That's pretty much it, okay? So yeah.
This slide, actually got me, interesting idea. Because when you're talking, about the initial language model, the thing is that, of course, you're obviously interested, in producing a good initial language model. Right?
Yeah.
I mean, you're not just interested, in a random outcome. Yeah. But history, what I mean is that there already, you are already implicitly, introducing, some kind of really, a reinforcement learning process.
Yeah.
So what I was really wondering about, the question is, how do we control, for bias, in a scenario in which, on the one hand, we are implicitly, introducing, some reinforcement learning techniques because we are both interested in introducing a good language model. And then we on top of that, we have the explicit, reinforcement learning process. So I think it's a little bit difficult to control. I don't know if there are really any methods for this,
Yeah, I think it's, yeah, of course, there are sources of bias that people do not account for because of technical reason. It's hard.
Yeah.
I know. What I can recall is that there are several papers now that instead of just using single reinforcement learning, they have like multi-objective reinforcement learning. That we could have like different reward models to try to other reward models to try to model other bias approaches, and then something like that. But you have to model that. But you have to model that. If your bias, if you cannot model your bias, you have it's a problem.
Yeah.
How do they various
Oh.
objectives?
Canalization or something. The easiest way. So now just, I may good on time. Just to finish, well, in the next 15 minutes, some emerging directions on what people are doing with this. Well, as you have seen, reinforcement learning for human feedback is not really complex, and also it's not really reinforcement learning because it's just the PP optimizer. But you know, a lot of people believe that reinforcement learning from human feedback is a bad name because there is not much reinforcement learning. You know, it's not like there is a notion of a state, and because it's like a bandit. You know that for those of you that know, but you know, it's just that what the people learn. That reinforcement learning from human feedback is like the term that predominates when people do that. But now there are some other approaches to optimize preferences that doesn't rely reinforcement learning. We're gonna cover them, okay? So just take into mind that, right? So, yeah, as usual, we can adapt a lot of techniques from statistics to improve a reward of preference, like best of friends sampling or rejection sampling. Okay, this is quite similar in a sense. So we have a language model. We generate options. We rate the options with a preference model or reward model, and then instead of just doing PPO maximizing, we can just fine tune on the best case samples. This is like generating then resample from the reward model and then fine tune on that. So this is what is called rejection sampling in the LLMs context. Okay, it's a very simple approach, but it also works in practice. You need to do PPO. Okay. Yeah, there is also a lot of work in changing the feedback. Okay, because until now you have to take into account that for a whole completions we just have one single reward, but a completion is made of different tokens. So if we could score each token, we have more information. Okay. The thing is, evaluating each token, each word in general text generation is hard, but it is being done in structured domains like reasoning. So we have a language model, okay, in which we just want to do some mathematical operation, and the output is like structuring the steps of a demonstration. Okay, this is a natural domain. So instead of just giving just a reward at the end of the whole generations, we can give a reward to each step on the demonstration. So then the model has more information. We are giving more feedback to control the behavior. Okay, instead of just giving a reward at the end, we can reward intermediate steps. This is being done by OpenAI or DeepMind, but it's, to my knowledge, it's only applied to mathematical reasoning tasks because you can decompose the generations. Okay, so you can give, okay, this step is good, this step is good, but the final step is wrong. So the model learns that this is because this is not the, okay, that's the, and this is what is called like process reward models. That's the name they want to put that, okay? Yeah, and also a very interesting approach, which is like, instead of from human feedback, yes, if we have a model that we can run results, we can have AI feedback, which in a sense is the same, but just changing the human for another model that rates, okay? And this was done by Anthropic, you know, the company, the authors of Claude, okay? But the name they call it was like constitutional AI. Okay, it was from December 2022. It's a quite interesting paper, okay? Because, well, they define what is a constitution, which is like some kind of principle, like, okay, you have to do no harm. That's a principle of the constitution. It's just a prompt, okay? So then they just use, they have a prompt, okay? Originally, the model gives a response that can be harmful, okay? So, but then they have the same model using a different prompt. It's like to criticize the response and then to rewrite the response to make it comply with this principle, okay? And now you have to consider that we have, okay, the first generation, the first completion, and then the second completion. So we can have two options, and then it's like we have preference data because we can then do a feedback loop. So the model learns to just directly generate the revised responses, okay? But in the end, it's the same loop, but instead of having a human rating this, it's the same model, just rewriting. That's it, okay? It's a quite interesting paper. Well, this is the same, but just expressing as different data because you have a model to choose the constitution, okay, and then you refine that. And also a very interesting approach, which is what people is using now for reinforcement learning from human feedback, okay? Instead of PPO, this is quite popular, especially in the open source communities. Maybe you have heard about that. It's direct reference optimization, DPO, which was from May last year. Okay. So the thing is, as we have seen in the error-related process, we have to first learn a policy reward model and then train our LLM with that. Okay. In this paper, they aim instead for just derive a cross-course solution. So we don't have to have a different reward model. Okay. And I mean, it's a very simple paper. The steps, okay. So we have, I'm just gonna review it quickly. We have our original model problem, okay, which is maximize the reward subject to the KL constraint. Okay. This is the optimal model. It's the Bayesian posterior. This is from the previous paper I told you. So you know the optimal model satisfies this is this one. Okay. But we are gonna, that depends on the reward. Okay. We can just solve for R. It's like despejar. Okay. And we get that the reward, the optimal reward, has this form. And then, since this is a closed form expression for the reward, we can just plug it into the predictory model. Okay. And now notice that we have an expression that doesn't depend on the reward. You only need the preference data, okay? We still need preference data, but now there is no reward. So we can just optimize this directly by taking the log like Jellyfoot, and this is direct preference optimization, which is like directly optimizing for base of data, but you don't need to use a separate reward model, okay? And this is like supervised fine tuning, but with preference data. The thing is, this is more easy to implement because you don't need an external reward model, and it works quite well in practice. But this is slightly different than PPO because here the data has to be produced offline before, and in PPO it's an online method, so you generate data while you are optimizing. So, I mean, there is a lot of discussion between which works best, if PPO or DPO, and yeah, PPO works best. Right? The first one, the one that uses around PPO.
Where's it?
Yeah, because it's online. And this, you have the other one. It's, I mean, they are quite close, but you're no. Okay. So that's
And the comparison is
yeah, there is no, yeah, as usual in deep learning, this is just so they have some benchmarks like summarization or safety tasks, and they just compute the uptime reward over a test set. Okay, that's it. So this is something I do. Okay, just to finish, if you're interested, I'm just gonna briefly going through some examples. Okay, but don't execute anything. Well, I have prepared some examples if you're interested, but you can have a look later or write me an email. Okay, so we have the two examples. They use the transformers library. Have you heard about that? I'm sure the high phase libraries. So they have a new library, TRL, which is for reinforcement learning from human feedback, and they have like PPO implemented and also DPO. So they have all the methods implemented, and it's quite easy to use. Okay, so the first example is to just tune GPT-2 to improve sentiment analysis. So we have as the reward model a sentiment analysis model, and we learn to maximize the sentiment of the movie reviews. I think this was completed here. I mean, I think they have, this was from the documentation. So yeah, this is the same. I mean, it's mostly data loading, but you can see that I wanted to show you as the training progresses by min matches, this is the main reward. Notice that the reward stabilizes in the top. Okay.
And the preference data is in interface?
No, in this case, I use just a classifier
Okay.
for positive sentiment or negative sentiment, and as the reward, I take the logit. Okay.
So you're not training a reward.
No, in this case, no, but you can train with this library too. I think. Well, I think. Yeah, it's a BERT classifier, and you take the logits for it works best. Yeah. Yeah.
Different approaches, also have the NRC approach, for example, we also have the Italia approach, and of course, the convention secret, and the way of expressing the so has there been, any theoretical people started on, because of this is the initial stage, and by definition, each initial stage, is of course, crucial, for what comes next.
Yeah.
So has there been, any theoretical people starting to talk, on what kind of sentiment analysis or just depends on the scenario, maybe on, exception of the, engineering,
Yeah. So the question is that types of analysis are very task dependent. And for sentiment analysis, I will not know in particular because sentiment analysis, like a solved task, is not very interesting. What is interesting is other tasks like improving security, safety, or helpfulness of an assistant. And there are some analysis of mostly of robustness of the reward model. But that's the most people are doing. Okay. Yeah. But it's mostly related to safety things. Sentiment analysis is just like a point task. It's quite easy to go apart.
Yeah, no, I mean, the thing, of course, it's computation is very easy. But the thing is that because many there are three main methods, which are NRC, and some other ones which are right now. But of course, they can be extended. So the problem is really, they use different metrics, on the one hand, but then, because of these different metrics, the results, they can actually deviate quite a lot. So that is for me. And so far, this is an essential part of the setup. It just seems important for me, to touch this slide.
Yeah, that's a good point. So that people, here is a very simple example, but people also use like different reward models, one for training and other for evaluation, to check if the both rewards are robust. Because you don't have the problem of optimizing just the first one, but that's like some kind of model optimization. So it's just, and people, if you want to get rigorous, use like different reward models of the same latent metric. So the results are consistent, but there is not more theoretical result than that.
Yeah.
Okay. So point. So yeah, just quickly, we optimize the reward, and then we can compare. I don't know. For example, we have these early John Wayne films look like abandoned police beating. We have a low sentiment, but the revision is a film is a realistic portrait, or was very happy. The model starts generating good things or positive things. The other example is more elaborated, is for safety. This is with a somewhat bigger model, but you can try on Colab. Okay, because I don't fine-tune all the layers, I just fine-tune a low rank approximation of some of them. And this is just to improve safety behaviors. Okay. So for example, I don't know, maybe you ask the model to create a phishing scam. And and the original model, it's open source. It's just complies, dear customer. We want to log in, so it's like typical scam message. But this is bad. So if we fine-tune the model with DPO, now the fine-tuned model, I install code them and I attempt to create phishing scams, and it gives a moralizing text. So to improve the safety and to avoid generating harmful outputs. That's another example I have.
You said that you fine-tune a low rank approximation. Can you explain very briefly?
Yeah, it's a. Yeah, I think. Can I?
Yes, there are.
Can I just? Oh yeah. So maybe we have one layer, like a linear layer or whatever. Okay, so this is the linear layer in the multi-layer perspective parts, but also the linear transformation in the adhesion layers. Okay, the thing is, this W matrix is maybe it's quite big because it's D1 plus D2, and these are two big numbers. But you can just decompose this U as a low rank approximation, like I don't know, U1 and U2, so that U1, this is a D1, of course, but a very like 8 typical one. And also D1 and D2 typically maybe are in the 2000 dimensions or whatever. So now the internal dimension is 8, and this is 8 by T2. So instead of having this quadratic amount of parameters, you express the weights this part, this way. So now the parameters are grow linear with the dimension. So you consume less memory. But this high phase automatically goes for you.
So in practice, you don't have to.
No. That's, of course, it's but that is it. So yeah, I can show you the code. But so the thing is, apart from TRL, high phase have a different library which is PEF, which is parameter efficient fine tuning. Maybe I can show. Yeah, I think cannot open a new. Oh yeah. And they have this LoRa methods. It's there are several techniques, but LoRa is just and it's just a function. You wrap the model in this, and they just convert the layers to that format. Okay, but yeah, LoRa. Let me show you typical diagram. What? No. And I have. Where is the? Yeah, it's this thing. Yeah, it's. Can we see that? Stop. Yeah, so you decompose this into a product of two matrix program, and you fine tune this. And the thing is, of course, this is empirical, but at least from my experience and other people, it works nearly as well as fine tuning the whole thing, and that's it. But I think it's because of the real model has a lot of knowledge, and this thing is just steering the behavior. So it's just a small change because the model, you are not injecting new knowledge to the model, you are just controlling the distribution of the outputs to avoid generating bad content or whatever. So using these approaches work very well for that task.
And to fine tune 7 billion parameters, as you said, what do you need? Like one GPU with how much memory?
16 gigabytes.
And that's
so Google Colab, you can do that. Yeah. If not, you need at least for a CBA model 80 gigabytes or more.
80 for the non low rank approximation.
Yeah, with no, yeah. So it's a good thing. Yeah, people are using this for like every fine tune. They just use this, and that's it. Okay. So I think we are mostly, yeah. These are the examples here. You can see now we can just our models can be secure and safe, and we can apply censorship to the models. So that's that's it. So yeah, I don't know if does anybody has a question, but that's pretty much for today. Any comments or questions? Or?
Yeah, that you could work it the other way around to make it.
And sensor versions. Yeah.
And
people are
use nasty.
Yeah.
So what is the control? I mean, you could get an open
model
and make it convert it, make it.
Yeah. The thing is,
trace it, etc. And
yeah,
load it somewhere and.
If you go to high phase, you know, they have this hub with the models. There are people doing that kind of thing. So you have unsafe versions of Llama 3 or whatever. Because yeah, you just have to reverse the scene of the rewards. But so people, you know, when Meta, Facebook released Llama 3, it's censored because they use RLHF. But then like 3 days later, in the high phase, they were already uncensored models. It's a good thing. I think I mean, maybe this is controversial, but I think it's good to have options. So then you just use whatever you prefer for your companies, okay? Yeah, the problem with RLHF is that if it's a model run by a company, the company gets to decide which values are inside the model. So with open source models, you can just change the behavior in this kind of techniques.
And all the unsensor models has been made starting with a sensor model and doing reference optimization, or
yeah,
there are not models like have been trained already without censorship?
Yeah, typically they start with unsensor, but you can also start from a base model. I think if you start with a base model, you need more data to adapt it to the chat format. Yeah. Yeah, or just
page for.
No, I mean not the
page for bad models.
No, there is no tag, but people just in the name of the model, they call it like unsafe YAML and sensor YAML. Okay. But yeah, it's
I'm always very cautious, in these scenarios about maybe somewhat philosophical, because recently mentioned constantly, I think that because I say philosophical that, I know to science and technology and so forth, in my case, the rest of us, we do. But I think, there are, I think right now, I mean, it's philosophical because right now, there are many constants. Just further, jumping off the conversation. So I think, on the one hand, I would like to bring up, what Carlos was mentioning, in last session, and this actually, caught my attention, about when he said, that, some models, were performing really well only on numerical tasks. Yeah. And because Carlos, focused so much attention, last session about how we could basically, statistically decompose, language, so I was just wondering, just to make the first point, and then very short point. I was just wondering, what would really be your perspective? I mean, we think that essentially, it's a matter of, having more GPU, at our disposal, or we think that maybe we would need, more understanding, of the way our brain and our mind, they function. So this will be, the first point, and the second point, very quickly. I mean, I'm really intrigued right now, about the challenge, posed by synthetic data. And I think, since they are, not only because of bias and other considerations, but just in general, I think, training in the near future, is going to become much more difficult, because of synthetic data. Because so far, essentially, we have been web scraping, the internet, and now it's not the case, especially, in generative artificial intelligence, we now have, this content, which is generated by artificial intelligence, but of course, this is an already modified content, so it's not human based,
Yeah, there is a lot of people now are starting to use synthetic data to fine tune and further train. That maybe there are some papers that are analyzing the impact of synthetic data and training like with the same feedback. And the thing is that the model degrades because it's like you lose diversity. Because in the end, synthetic data generated by a model is quite more unimodal because we have approximated the mode of what we want. Okay, so if you generate data from that, it's less diverse than the data of the internet. And then if you fine tune that on that, you're only approximating just a single mode. So it's maybe for less, but it's you lose diversity. Okay.
Yeah, I'm very sorry, I was just laughing, because for those of you, who have Twitter, actually, in the last few days, it became very prominent, a picture of, Mother Teresa, with synthetic data, precisely, she was asked, about, the way, to illustrate, with daily, something like this, I'm sorry, it's just really funny, to illustrate, the way she was fighting policy, and then, actually, you have, Mother Teresa doing kickboxing, essentially. we find, some of the outcomes, of using synthetic data, so imagine, actually, having master theories and, doing kickboxing, in order to illustrate, her struggle against poverty, so, well, that's it.
Yeah, the first part of the first part of your question, I think what people are progressing, especially in companies industry, is just like scaling or more GPUs, making bigger models or more data. That's not because I think that's the easiest way of. I mean, it's not easy because it's an engineering effort, but it's just like the direct to achieve to get some gains. But the gains are starting to be incremental because the quality of the data on the internet is limited. I don't think there is some kind of, well, that's a personal opinion, but you cannot be better than what you try out training. Maybe with synthetic data, you can help a little bit, but it's not gonna expect, because it's not, open text generation is not a constrained domain like playing Go, in which you can have a simulator and you have a good reward, a perfect reward. In a game like Go or chess, you can perfectly learn, but because the domain is very constrained. So you have a perfect reward, which is you win or you lose. But with just general knowledge and innovation and text generation, there is no reward. So I don't know if there are no other developments. I think we'll hit a bottleneck for stampede. That's it. Thank you.